Hi everyone, let's solve today's daily challenge, that is count elements with maximum frequency. So in this question we are simply given an array which has some positive integers and we need to return the total frequencies of elements in num such that those elements all have the maximum frequency. Okay, and the frequency, you know what frequency means, that is the number of times a particular number appears in an array, that's called frequency. So it's an easy question, obviously, because all you need to do is you need to return the total frequencies of elements in nums, right? Such that those elements all have the maximum frequency. So basically, if we see at this particular test case, right? So let me show you like this. So let me simply draw it here. See, these are the distinct elements 1, 2, 3, 4. And 1 appears how many times? 2 times. 2 appears how many times? 2 times. 3 appears only 1 time. And 4 also appears only 1 time. So I have to take all the max frequency elements. So max frequency is 2 for this particular array, right? So what are those elements who have the maximum frequency? 1 and 2. So number of occurrence of these elements. So you can see it is 1, 2, 3 and 4. So you have to return 4. Correct. Let's take second example. You have 1, 2, 3, 4, 5. When you're 1, 2, 3, 4, and 5. So here you can see that each and every element is having a frequency of 1 only. So in this case, our maximum frequency is what? 1. So the numbers with this frequency 1, they appear how many times in the array? 1, 2, 3, 4, 5. So 5 is going to be the answer. Now, let's see how to solve this question, right? So here already you can see that you have to count those elements who have the maximum frequency, correct? So what you will do is you will create a hash map and then you might try to traverse this hash map and calculate what max frequency. So one traversal here of the array to form the hash map and one traversal to of the hash map of the hash map and to calculate max frequency, and another traversal of the hash map to count the number of elements having this max frequency. Having max frequency. So you can see that it will be how many traversals? 3 traversals, right? It will be big O of n. It can also be big O of n in the worst case, big O of n again. So now, do we actually need so many traversals? So obviously we don't need this particular traversal. Okay, so we can optimize this traversal. See, although the time complexity is going to be big O of n, but still it's big O of n plus n plus n. So if we reduce this, definitely the time will be lesser. How can we do this? While, right, so if we trim this right here while traversing here, right, we can keep a track of a max frequency variable. And if we find, first you hash it inside of the hash map and then you simply check if this particular value is going to be greater than the max frequency. So make max frequency equal to the frequency that you currently have, right? So this way you will be able to get the max frequency inside of the array traversal. That is, while you are traversing to form the hash map, you will also calculate the max frequency and then you will go and calculate number of elements having max frequency. So for that you will do an O of n traversal of the hash map. So now the time complexity has been reduced to this. Now can we reduce this time complexity further? Oh yes, definitely we can. So let's see. All we have to do is what? We have to take all these elements, right, which have the maximum number of frequency, right? So while we are traversing in the hash map, right, sorry, in the array on and calculating the max frequency, let me show you. What you'll do is you will start from 0 to n, iterate inside of the nums array and hash the values inside of the map. So you'll say nums of I and say plus plus, and here only if let's say this mp of I, right, this particular thing is greater than max frequency. Okay, you will do what? You will make max frequency equal to this mp of nums of I, right? Now here only what you can do is also add this particular element inside of your answer, right? So let me take an answer variable which is going to be 0. See, all you have to do is calculate the occurrences of these numbers which have the maximum frequency, right? Let's say you have this answer, right? Or let's say this is count. Okay, so this is count variable. It's initially what? 0. So what we will do is, when we will find that this mp of nums of I plus plus is greater than this maximum, what I'll do is I'll set my count is equal to this max frequency only. Okay, now else what I'll do is, else if let's say this turns out to be equal maximum frequency. That means while iterating I have reached to some maximum frequency, so I have to do what? Count plus equal to this max frequency. Okay, so if you have not gotten it, let me do a dry run for the first example, right? So what we have 1 2 2 1 3 4. Okay, let me go down below here. 2 2 3 and 4. So we have this max frequency variable which is initially 0. We have a count variable which is initially 0. Now this count is responsible to return the answer in the end. Okay, now what we'll do is we'll start iterating. So when we will come here, so look at the code. When we come to this condition, right? So then what we'll do is we'll keep this in map, right? So for 1, corresponding to 1, we have 1 frequency, and currently max frequency is less than this 1, so we'll update it to 1, and also we'll update count to 1. Come here and you have 2 have again frequency of 1. So then you will fall under this particular condition, that is your current map value for 2, or the frequency of 2 is what? 1, which is also equal to your max frequency. So what you'll do is you'll do 1 plus whatever is the max frequency, so you'll get 2. After that you will come here, and as soon as you come here you can see that okay, I need to reject all of this because I don't know whether it was the max frequency or not. Here one another one is supposed to be there, right? So what you will do is, now you will go under this condition that whatever nums of I is, so it's 2, right? So what you will do, you will make it 2, and you will make your count equal to 2 as well, so it will become 2. All right, then you will come to this particular one here. As soon as you come to 1, you can see that the frequency it has is equal to max frequency now, because it will be updated to 2, and you can see you will fall under this condition. So when you'll fall under this condition, what will happen? You will increase your count with the number of your max frequency. So you'll increase it by 2, that is 4, right? So you'll do 2 plus 2, and your max frequency is going to be still the same. Then you will come at 3, and you will not fall under either of these conditions. Similarly for 4, you will not fall under either of these conditions, and after all these iterations you have to simply return this count value, which is 4, and which is your answer also. So I hope you are kind of understanding this. Let us take another example. Let's say we have 3 4 5 3 3 and 6 7 8, and let's say 5 and 5. Okay, let me take this 3. Okay, here. All right, now you can see we have this array. Again, let me initialize my max frequency to 0 and my count to 0 as well. As you go, you will see this is 3, right? Start creating a map also here. Look, wait, we will write the map here. Okay, so for 3, your frequency is 1, which is greater than the max frequency. So you update the max frequency, and count will now become 1, equal to max frequency. Okay, then you will come to 4. So you will hash your 4 inside of your array. Now your force frequency is equal to max frequency. That means you have to add this max frequency to count. So you will get 2. Then you will come to 5. Again, 5 has a max frequency which is 1. So you will add this number which appears with max frequency also, and you will get 3. Now you will come at this 3. As soon as you come at 3, you can see that oh shit, we did wrong calculation, so we have to refresh it. So how do we refresh it? We will say, for all these, right, for all the values that we consider up till now, please do not include them in the answer and include for this 3, for this max frequency number, right? So what we'll do, we'll update the count to what maximum frequency, we'll also update the max frequency variable. So now this is the condition. Now you'll come to 6, again hash 6. Now 6 will not fall under any of the conditions, you will keep iterating. Again come for 7, 7 is not also not going to fall under any condition. Come to 8, it also doesn't fall under any condition. Come to 5, okay, now 5 will become 2. So you can see that max frequency and 5's frequency are matching, so you will add this to your count. What you'll get, you will get 4. Now you will come at this particular 5 and you will update it to what 3. Now again you will say, wait, we again did wrong calculation up to here, because my maximum frequency was what 3, and I was not supposed to calculate for all these elements, right? So now it has been updated, the count will be updated to 3 itself. Now you will come at this particular 3 and you'll update it to 3. Now this is equal to your max frequency, so you will add another 3 here and you will get 6. Now you can see after all the iterations you are getting 6, which is also the correct answer, because 3 and 5 are the only numbers having the maximum frequency of 3. Now why does this approach work? This approach works simply because what you are trying to do is, you're trying to take a max frequency, right? And up till here, up till this 5, right, the max frequency was 1. But as soon as you hit this 3, you said, okay, wait, the max frequency is actually 2 and not 3, right? So if it's actually, sorry, not 1, if it's actually 2, then that means for all these numbers I did wrong calculation, and for this particular number I have to add it, right? So you obviously you have to reject the numbers who doesn't have a maximum frequency, correct? So that is the reason this approach works, and this is what you have to do. Now what you are doing is, you are doing this in a single pass. That means you are iterating from I0 to n, and within this particular traversal only you are calculating the max frequency as well as the count of the numbers which appear with the max frequency. So I hope you understood the solution, what we are doing, right? And the time complexity is obviously big O of n, and the space is also going to be big O of n. Now let us go ahead and quickly see the code for it. So what we are doing, we are taking a map and we are taking this max frequency and count variable as I showed you in dry run, and then we are simply iterating in the array. Then increment the nums of I value, that is hash it, right? Calculate the frequency of nums of I. Now if this frequency happens to be equal to the max frequency that you have, then you have to do count plus equal to this max frequency element. Then otherwise, let's say this max frequency, only else if, right, that this particular frequency that you have is greater than the max frequency, then you have to update the max frequency and also the count, because as soon as this happens, you know that for the earlier values you did wrong calculation, right? And after this particular iterations you have to return count in the end.